Good afternoon, guys. Welcome to my YouTube channel. Today we're gonna solve an application of function. This is video number 2. The previous video we were looking at the functions. We were solving how to find the domain range of the function. In this opportunity, we are gonna solve a real world problem of a function. So, if you guys would like to know which book I'm getting this problem from, again, I'm using the Calculus, Public Transcendentals, and the author is Bright and Conrad, if you guys like to know. I'll read specifically talking about the problem number 19, and it is about domain in context. Let's read the instructions. Determine an appropriate domain of the function. Identify the independent and the dependent variables. So the problem, let's read the problem. A stone is thrown vertically upward from the ground at a speed of 40 meters per second. At a time t equals 0, its distance d in meter above the ground, neglecting air resistance, is approximated by the functions f of t equal to 40t minus 5t squared. So the first step is to understand the problem. So the problem is talking about a stone that is thrown on the air. So a stone is thrown in the air, and you're gonna represent the, we're gonna describe on the Cartesian plane the function. So we have 3 events. First of all, or the first event is when the stone is thrown, right? When the stone reach the highest point, and when the stone hit the ground. So that's what the problem is talking about. So we have a function f of t equals 40t minus 5t squared, and since we gotta find out when the stone is thrown and when the stone hit the ground, so in mathematical terms, what we gotta do is equalize the function to 0 in order to see those 2 factors. So basically, f of t equals to 40t minus 5t squared. So we gotta equalize that function to 0. So 40t minus 5t squared equals 0. So the first step that we can obviously see is that we gotta factor the binomial. So the factor of 40t and 5t squared, that is 5t. Factor what? 40t divided by 5t, that is 8 minus, right? 5t squared divided by 5t, that is t, right? And that's going to be equal to 0. So the first step was to, right here we have the expression factor. And then the next step is to express or find the value of t. And right here we have a product. This is one product and this is another product. And so when we are representing a product, it is either because the first product, which is phi t is equal to 0, or the second product, which is a minus t is equal to 0. So what we have done over here is equalize to 0 both of the factors. And now we get isolate dt. So at the left side we have phi t equals 0. In order to isolate dt, the only one number that will isolate it is multiplying this expression by 1 divided by 5. And let's see what we have as a result. 1 times 5, that is 5 divided by 5, that's 1 times t, that is t. T equals to 1 times 0, that's 0 divided by 5, that is 0. T equals 0. Okay. Then on the right side, we have a minus t equals 0. So in order to isolate t, we need to add on both sides t. And let's see what happens. T plus a minus t, we cancel the t's, and we only have 8 on the left side, and then on the right side, 0 plus t, that is t. And a equal t is the same as how t equal 8. So what we have found over here is that t equals 0 and t equals 8, the function is passing through the x-axis, or in this case, which is called t. T equals 0 and t equals 8. But let's start. Let's do a board and see the description of the function, right? So let's call the first column t and the second column f of t is equals to 40t minus 5t squared. Alright, and let's see what happens when t is equal to 0. F of t is going to be 40 times 0 is 0 minus 5 times 0 squared, that's 0. 0, so that's going to be the first point on the Cartesian plane, right? Right, let's make the Cartesian plane. So this is t. This is the distance. All right. Let's see. So we have found a point so far, 0 in time 0 in distance. That's 0, 0. Alright, let's find another point. What happens when t is equal 1? How much is going to be f of t? 40 times 1, that's 40, minus 1 squared is 1 times 5, that's going to be equal to 35. 40 minus 5 is going to be 35. So another point is going to be 135, right? Let's see what happens when t is 2. F of t is going to be 40 times 2, that's 80, minus 2 squared, that's 4 times 5, that's 20, 80 minus 20 is going to be 60. So 60, 35, to 60. There is another point on the Cartesian point. Let's see what happens when t is 3. F of t is going to be 3 times 40, that's 120, minus 3 squared, that's 9, times 5 is 45, 120 minus 45, it is 75. Okay, so so we throw the stone, and after 3 seconds, the stone had reached a distance of 75 meters. So let's see what happens when t is 4. So we're gonna have 40 times 4, that's 160, minus 4 squared, that's 16, minus 5 times 16, 5 times 16, that is 80, right? 6 times 5, that's 30, 1 times 5, that's 5 plus 3, 80. So 160 minus 80, that is gonna be 80, right? Okay. Right. And now let's keep let's see what happens when t is equal 5. F of t is gonna be equals to 40 times 5, that is 200, minus 5 times 5 squared, that's 25. And 5 times 25 is 125. 200 minus 125, that's gonna be equal to 75. So when t is 5, f of t is gonna be equal to 75. So it looks like the highest point that the stone reached is 80 meters. Once after 4 seconds. Let's keep adding the numbers, see what happened. What happened when t is equal 6? So we have 40 times 6, that's 240, minus 5 times 6 squared, that's 36. 5 times 36, 5 times 36. That is 210. 210, 240 minus 210, that is, let's see, again, 240 minus 5, 6 times 4, 24. 240 minus 5 times 36. 6 times 5, 30, we have 3. 6 times 3, that's 15, plus 3, that is 18. We got 18, 180. Okay, so 240 minus 180, that is 60. Okay, so when t is 6, f of t is gonna be 60. See what happened when t is 7. So we had the function, we substitute 7 on the function. 40 times 7, that's 28, 280, minus 5 times 7 squared, that is 49. And 5 times 49, that is 245. 280 minus 245, that is equals to 35. Right? Alright, when t is 7, f of t is going to be equals to 35. Now let's see what happens when t is 8. So let's substitute the value of t for 8. 40 times 8, that's 320, minus 5 times a squared, 64, and 5 times 64, that is 5 times 4 is 20, we have 2, 6 times 5, that's 30, plus 2, 320, and 320 minus 320, that is 0, all right? So the description of the stone is gonna be like this. Okay. And now, let's see which one is gonna be the domain. The domain of the function. So we have the function which is f of x equals to 40t minus 5 t squared. So same the function, we can add any sort of number to the function, and that function is going to give us any real number as well. But if we focus on just on the graph or on the description of the stone, right? The problem is asking us about the domain inside or the time that had passed from when the stone is thrown until the stone hit the ground. And we can see over here, and that is from 0 all the way up to 8. So that is the domain. And then we had another question. Determine an appropriate domain of the function. We already found it. And then it says identify the independent and dependent variable. So the independent variable of this type of problem is the time. And then the dependent variable is the distance. So the distance of the stones depend on the time. How long had it passed since the stone was thrown? So that's basically the dependent variable, the distance. The distance depends on the time. And we could also add to this problem the range. We could be able to find the range on this problem. And so we know that the domain goes from 0 to 8. And the range, let's focus on the graph and see that the range goes from 0 to all the way up to 80. Okay, and that's the solution. Please leave me any comment. Appreciate those that is gonna subscribe, and any improvement that I need to do, it will be appreciated if you guys put it in the comment. Thank you for listening. Have a great afternoon.